What is redox? Yes, ma'am. Yeah.
It's like oxidation states. So redox, I think, I know it's like red and ox, and the ox is oxidation, and I think the re is reduction.
Perfect. Oxidation. So when you get the word redox, the reason why they use the word redox is because you have a word that's called red, which is short for reduction, and ox, which is short for oxidation. Now, this may look like a new concept, but it really is not. Okay? Let's take a step back in time when I had pure old-fashioned sodium, okay, and I'll pull some out in this next week. And when we had sodium, we knew that sodium has one valence electron. We know it's a big atom, holds on to electrons loosely. It's a metal. Then when we put it in close proximity to something called a nonmetal, who is smaller, has more valence electrons, and because it's smaller, it has a higher effective nuclear charge, what did it do? Well, my friends, in chemistry, the nonmetal, if you remember, okay, moved the electron, and we made something called a transfer happen. Okay? So my friends, in chemistry, we saw that there was a transfer from electrons from the metal to the nonmetal. Maybe. Okay, so there was a transfer. Maybe. I don't know what we're seeing, transfer. Okay? I was being crazy here, but now we're getting crazy. Okay, it doesn't want to play with me nicely. Alright, so there was a transfer. No? Maybe there was a transfer. I moved that dot, now I'm in trouble. Alright, so there was a transfer. Okay, yay! Okay, so electron went from the metal to the nonmetal. And remember that this lost an electron, so it became positive, and this one gained. That's old hat. We had that already. Now, we're going to name these specifically. Anytime we have a transfer of electrons, it's a redox reaction because someone lost electrons. And usually who loses is the metal because the metal holds on to them loosely. So the metal loses electrons and the nonmetal gains. And what happens is this becomes positively charged. This one becomes negatively charged. And we have some distinctive names now. When you lose electrons, we call it oxidation. And when you gain electrons, this sounds weird, it's called reduction. Now it sounds, how can I gain electrons and cause reduction? Well, what was the charge of chlorine before it gained an electron? What's the charge of any atom? 0. Any element is given a 0. A standalone element is a 0. Guess what? We learned about that. Protons equal electrons. You say atom, I say neutral. Atom, neutral, and part of USA. I think I messed it up. But the point being, whatever, the point being is that the chlorine was 0. It had equal number of electrons and protons. When it ripped an electron away from the sodium because the difference in electronegativity was great, all of this is review, this became -1. Its charge went from 0, and I can write this. Chlorine went from Cl0 to chlorine -1. And last night I called these charges that atoms become oxidation states. So chlorine went from 0 to -1. How'd that happen? It must have what? Gained an electron. Now notice, on both sides of my reaction, I do not have, I have the what? Conservation of mass, but I do not have the conservation of charge. This whole side is 0, this side's -1. What did chlorine get from the sodium? The chlorine got an electron. So we write an electron here. Chlorine, excuse me gentlemen, gained an electron to become chlorine 0. Now this is called a half reaction because it's only half the story. Now this half reaction, where chlorine gains one E negative. The E is an electron. It's always negative. You can see a negative 1 and a 0 is negative on this side. This side is also negative 1. But chlorine gained an electron from the sodium, became negative 1, and this is what you did last night. We see a change in the oxidation state. Because it's going down, because it gained a negative, we call it reduction. So my friends, the nonmetals that we learned in the upper right-hand corner of the periodic table, they tend to gain electrons, which means they tend to get reduced. Their charges go down. Now, the weird part is sodium lost an electron. What's the half reaction associated with the sodium? Well, the sodium is Na0. It's an element, and it went to Na plus 1. Now, is the charge in both sides of this, quote, half reaction the same? No. What did sodium lose? Right. Now, if you lose heat, where do you put it? Reactant side or product side? Product side. So we're going to put the electron that it lost on the product side. There it is. So sodium becomes sodium plus 1. Its charge goes up by losing electron. And remember that losing electron is oxidation. There's a reason for that. I'm going to explain in a second. But to help you remember that, last night, remember that Leo, the lion, does what? Okay. If you were actors, I'd fire all of you. Okay, what's your motivation here? Leo, the lion, says, grrr. Right, Leo. Lose the electron. So Leo. 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 Leo, the lion. So losing electrons is oxidation, says grrr. Gaining electrons is reduction. So we're passing electrons around. We've done this before. We called it ionic bonding, but now we're studying it in detail. So this is really a unit where we're reviewing things we've learned, but with a little more detail. So we have to understand the metals who lose is being oxidized. Nonmetals who gain is being reduced. We've covered this in terms of why it happens, but not in terms of these types of ways we're looking at it. So this is called a reduction half reaction. Why a half reaction? Because it's half of the process. It's gaining, and this one is losing. You can't get a gift unless someone is giving it. This guy is gaining the electron, the gift. This guy is giving it. So this is a half reaction for reduction, a half reaction for oxidation. Notice the difference. Reduction always has an electron in the reactant side. Oxidation always has an electron on the product side. Why did we spend last night together looking at oxidation states? Because if there is a redox reaction and electrons are passed around, this is important, the oxidation numbers will change. If I ask you today, is this a redox reaction? You look to see if the oxidation numbers change. That's the first skill. You have to be able. So let's step back for a second before we continue with today, which is the second skill. If I was to give you something like this, magnesium, okay? What's the oxidation number of magnesium? It's an element. Clearly people did not watch. If it's an element, it's 0. Protons equal to electrons. There's no charge. It's 0. Anytime you see an element hanging out by itself, it gets a 0. So what about this? H2, what's its oxidation number? Is this an elemental state? Yeah. So in nature it exists this way. Is there a charge to H2? So it gets a 0. What about zinc hanging out by itself? 0. Okay. Now, what about something like this? Na2S. What is the oxidation state of sulfur? Now, the whole thing does not have a charge, does it? So the whole thing is 0. We did this in bonding, right? So I look up sodium. Sodium's the positive one. It's a group 1 ion, so it's plus 1. How many sodiums do we have? 2. So the overall charge due to all the sodiums is plus 2. Plus 2 plus what number is 0? Minus 2. There's only one sulfur, so the individual charge of the sulfur is negative 2. I am after. Why am I after? I want to see if they go up or go down. Is there oxidation or reduction? So what if I give you something like this? Nah, bro. NaBrO4. Now I'm giving you 3 elements. Okay, well, if you look up bromide, it's got a bunch of different charges. Sodium and oxygen basically only have one choice, so I start that way. Sodium is plus 1 individually, plus 1 overall. What's the overall charge overall? 0, because there's no charge. Very good. Oxygen is what charge? It's given to you the upper right-hand corner of the periodic table. Negative 2. There's 4 of them. So negative 2 times 4 is negative 8. So a negative 8 plus what number plus 1 equals 0? Plus 7. Since there's only one BR, the BR is plus 7.
And that would be one of the choices under B?
Yes, and that would be like given the following elements, what is the oxidation numbers of bromide? You'd say plus 7. Or it could be a part 2 question where you just write it in. And that's how you figure out from the ones you definitely know to one that has multiple charges. Okay? Now we did this already, didn't we? Okay? Remember this, guys? Remember we had, let's say, PbNO3,4. Now it gets crazy, right? Now what if I wanted to know what the charge of the lead is? Now lead can be plus 2 or plus 4 from the periodic table. So I can do what? A little bit of a trick here. I know the entire nitrate ion is what charge? Negative 1. So there's 4 of them. So this is negative 4 overall. What's the charge of my lead? Plus 4. So there's ways to use that like we did before. Now, what if I get a little crazier? What if I do something like this? What if I give you this? MnO4 negative. What do you think that means? The whole thing is not 0, it's negative 1 now. So each oxygen is negative 2. I know that from the periodic table. There's 4 of them, so it's negative 8 overall. What's the charge of the manganese? Plus 7, and that's the charge plus 7. All right, well, now what about this one? Hardest one I give you. Potassium dichromate. Watch this, party people. I want to know what the oxidation number is of the chromium. Now, if you check out chromium on that reference table, chromium has a bunch of different oxidation numbers. So you got to figure out from the ones you know. What's the oxidation number of oxygen? Negative 2. There's 7 of them. So what's the overall charge due to all the oxygens? Negative 14. We kind of did this. We were naming chemicals, right? Now potassium only has one choice. It's an alkali metal. It's plus what? 1. There's 2 of them though. So overall it's plus 2. This whole thing has to equal what? 0. Okay. So what charge do I need for all the chromiums that'll give me 0? Negative 14 plus what number is a plus 2? Plus 12. Someone said it. Good. But plus 12 is not your answer. Because plus 12 is for all the chromiums. How many is there? So each chromium is plus 6. I am after the individual charges. That's what I want. Because if chromium goes from plus 6 to plus 3, what's happening to it? If its charge is going down, is it getting oxidized or reduced? Charge is going down. It's getting reduced. That's what reduction means. It's gaining negative charges. We'll talk about that, and we'll do something called half reactions next to follow that. But we can't do half reactions. We can't ask if something's getting reduced or oxidized unless I can first do this skill. Okay? Absolutely vital that you can find the individual oxidation state so we can track. Is the number going up? Is the number going down? Or here's another Regents question. in the following reaction, who's getting oxidized, who's getting reduced? And it could say neither. If the reaction is not a redox reaction. Let me give you an example. Okay? Let me give you an example. We talked about this. Check this out. What if I had sodium chloride and I had potassium nitrate? Just to give an example. What kind of reaction would happen if I split the ions and I switch the pairs? What do we call that? Yeah, double replacement. So Na is +1, chlorine's -1, potassium's +1, nitrate's -1 complex. So we would write sodium nitrate. Oops, I forgot the Na, NO3. And then I would have potassium chloride. My friends in chemistry. Everyone see what I just did here?
Yeah.
I double replaced the ions. Sodium with the nitrate, potassium with the chlorides. We've done this a million times. In fact, neutralization is an example. If Na is +1 here, wouldn't it be +1 here? This is -1. This is. Can you see that the oxidation numbers are not changing here?
Yeah.
So this is not a redox reaction. Now, if you weren't sure, assign all the oxidation numbers. You'd see this is still +1. This is +1, -1. Nitrate's still -1. You would see there's no change. So this is there's no redox going on here. But what if I gave you the following? I'm going to do this reaction in front of you. What if I took zinc, okay, and I dropped it in acid? Okay, and what does it make? Well, it makes, by the way, what kind of reaction am I going to do here? The zinc's going to replace the H. What do we call this? It's called single replacement. Excellent. Redox reactions love single replacements. Now, my friends in chemistry, here's what's going to happen. Zinc is going to get to zinc +2. Okay, let's assign oxidation numbers. Zinc is what charge? It's a standalone metal. What's its charge? 0. H in front, like all acids, it's the H is what charge? +1. What must be the chlorine if H is +1? Good. This is -1 individually, -2 overall. The whole thing has to be a 0. So this must be +2. Zinc is +2. And if you look up zinc on the periodic table, it becomes +2. And of course, I forgot to finish this. This is H2. What's the charge of H2? 0. Are the oxidation numbers changing? 0 is going to zinc +2. H plus is going to 0. Who is gaining negatives? Whose charge is going down? Well, the chlorine's not changing. Here's a Regents question. Which of the following is neither getting oxidized nor reduced until you say chlorine? Just like these guys are not getting oxidized or reduced. So chlorine's not doing anything. Whose charge is going down? Hydrogen's going from H plus to H0. It's gaining electrons. From who? Who is losing electrons and becoming more positive? Zinc. So you can see clearly, people, that this is a redox reaction. Let me give you a little hint. Anytime that they ask you, is this a redox reaction? Look for a standalone. Here we have 2 of them. There's a standalone. There's a standalone. This is a redox reaction. If you find yourself at 0, it's going to become something other than a 0. Oxidation numbers are changing. Electrons are passing around. So, let's start with this reaction here. All right? So I have some hydrochloric acid. Okay? Labeled. All right? So people don't yell at me. Okay, now, I'm going to take some zinc. Okay, there it is. Nice shiny metal. All right. Now, you may recognize this demonstration. I'm going to put the shiny metal in here. What do we see? We see bubbles. Bubbles of what? What are we generating? We are generating what? Look at your reaction. I dropped zinc into hydrochloric acid. What am I making? Hydrogen. This is exactly the reaction I did to make the hydrogen gas balloons, or the bubbles early in the year. Now watch what happens. Okay, think about this for a second. Up here, okay, if you think about the reaction for a second, here's my zinc atoms. So here's zinc atoms right here. Zinc 0 atoms. Right there. What's happening? And you guys see that or no? Okay. So there's my zinc 0 atoms. I have what in an acidic solution? I have H pluses. Now, what is zinc good at doing? What is metals good at doing? Losing electrons, which is called what? Leo. Oxidation, right. So my friends in chemistry, this H plus comes in contact. Now think of it two ways. H plus is really a proton. A proton is a tiny, tiny, tiny little positive. Because it's +1 in a small area, it really attracts electrons. H pluses are like heat-sinking missiles for electrons. So these H pluses go after the electrons of the zinc, or you can say the zinc pushes its electrons to the H pluses. It's a good combination. H plus is, we would say in AP Chem, has a high charge density. If I'm +1 spread out over a large area, and someone hits me, you don't feel all my positive. If you put my +1 in a small area, I have a higher attraction. So protons are pretty tiny, and they're positive, so they attack the what? The metal, and they're able to pull the electrons away. Now, zinc loses 2 electrons, and what does it make? It becomes aqueous zinc +2. This solution's going to get cloudy with zinc +2 ions. What does the H pluses do? Well, the H pluses gain 2 electrons and become H0, and they bond to themselves, and that becomes the gas that's liberated. There's a transfer of electrons here. In fact, if you don't like that, let's go play an animation that shows that better than my drawing. Okay? So let's see what we have here. You got hydrogen, let's just play it.
Hydrogen gases
Maybe not.
and zinc ions form in the solution. The solvated hydrogen ion is represented as the hydronium ion, H3
Let's watch.
hydrogen ion, and zinc ions form in the solution. The solvated hydrogen ion is represented as the hydronium ion,
H3O plus.
H3O+.
Oh! What was
In
that?
this reaction, zinc is oxidized.
What was that? What? Oh! What was that? That was the redox right there. Where electrons go to? Boom! Okay?
Zinc is oxidized and hydrogen ion is reduced.
2 hydrogens come together, become a hydrogen molecule. So there you go again. Do it again. There's the redox.
Ion, H3O+. In this reaction, zinc is oxidized and hydrogen ion is reduced.
Why is it oxidized? What does zinc do? Watch the electron. It went from the zinc, the metal, to the oxygen, or eventually the H.
In this reaction, zinc is oxidized and hydrogen ion is reduced.
There's the H2 that comes together, becomes hydrogen gas. Okay. Let's stop this reaction because I don't want to eat away all my zinc. Okay, but you can see the white film on it. That's the zinc ions. Okay, now put this away. Let's bring some copper in. Okay, we know it's a copper solution. I know it's a copper solution because what? Why do I know it's a transitional metal solution? By the way, is zinc a transitional metal? No, that's why it was a clear solution. Copper, okay, is a transitional element, so it makes complex ions with water. All you have to know is that transitional elements in solution make color. Now, what I'm going to do is do another redox reaction. Now, let me think about this for a second. Let's think about the reaction for a second that we just did. Okay, I gave you the reaction. The first step is to assign oxidation numbers. Let's go write some net ion reactions. Watch how I do this. Now, half reactions are about who's getting and who's losing. Let's start with the zinc. Zinc 0 becomes what? What charge does it become? Right, so I'm going to pull the zinc +2 out of the compound. That's all I care about. So I'm going to take zinc, who is already on this side. And by the way, I think that this one I just gave you, did I just give you the wrong one? Where's the half reaction one? Writing half reactions. Did I give you one? Well, that one you're going to eventually have to have, but I want you to have the half reaction writing one, so I gave you the wrong one again. Okay? So hold on, party people. Here we go. This is what I want you to have. No? It's this one. Okay, here we go. The one that says writing half reactions. Do you have that? Okay, some people don't, maybe they don't. Number 3 is what you want to go to right now. Who doesn't have the writing half reactions worksheet? I know you guys don't, because you were bottom. Everyone have it? So we're doing number 3 right now. We have zinc plus hydrochloric acid making zinc chloride H2. That's what we just did. That's what this reaction is right here. Okay. You don't have one?
Yeah, no, wrong one.
This one says writing half reactions on.
Yeah, but it's like not.
Okay, so who doesn't have it? Everybody?
Yeah.
Yeah, that was the more. Yeah, that we need that tomorrow. Everyone have it now, besides the table? 1, 2, 3, 5. 1, 2, 3, 4.
Yes.
Okay, so we do number 3 right now. Okay. So we're passing electrons from the what? Zinc to the H pluses. Now, here we go, party people. We assign oxidation numbers first. First skill. We just did that, so go through that now. Standalones are 0. By seeing a standalone, I know it's a redox reaction. Why? If I have a 0, it's going to become something other than a 0. If you don't like that, assign oxidation numbers and see if they're changing. If they're changing, electrons are being passed around. You've got yourself a redox reaction. Now, what we're going to do is pull out the elements who are involved in the passing around of the electrons. That's what a half reaction is. There's 2 parts. Someone's giving and someone's losing. So I'm going to pull out the zinc first. So the zinc comes out. It's on the reactant side, so it stays there. It becomes zinc plus 2. Notice I'm pulling out only something that is having its ions being changed. So zinc 0 go to zinc plus 2. Now, once I pull out one of the 2, and it doesn't matter which one you start with because there is 2, as long as they stay on the same side, and I pull them out of their compound, now I have to balance the charge. There's 1 zinc, 1 zinc. This side's 0, this side's plus 2. We can't do that. We have to balance the charge. How many electrons are involved? And where do they go so that both sides of a half reaction or any kind of process has the same charge? So how many electrons are involved to go from 0 to plus 2? 2. And where would I put them? If you're not sure, let's say I try over here. You put electrons as 2e negative. There's 2 electrons. Each one's negative 2. Now, if I was to put the electrons on this side, by the way, it's incorrect. A negative 2 plus a 0 is negative 2. This side is plus 2. We did that wrong. Your check is to make sure that both sides of a half reaction have the same charge. So we put plus 2 electrons over here. 2e negative.
So that would make it 0.
Right, because a negative 2 and a plus 2, both sides 0. That's your check. This is a part 2 skill you have to do. They're going to ask you to write a half reaction in the part 2 of the test. There's no multiple choice in the part 2. Okay? So clearly zinc got what? Oxidized or reduced. Yeah, believe in yourself. It got oxidized. My friends in chemistry, standalone metals can only get oxidized. Why? Standalone metals can only become positive by losing electrons. Think about this. If heat is on the product side, you release heat. Okay? Now, who got reduced? Well, write the other one. H plus becomes what? H0. Now follow me here for a second. Okay, now there's the difference of how many electrons? 1. And I'm going to put the 1 electron here because That'll give me a 0 on this side and a 0 on that side. Now for the Regents, if you left it like this, totally acceptable. But this isn't the best practice. Because really, HO doesn't hang out by itself. Really, it bonds with itself to become H2. That's what you're seeing fizzing. Okay? And because I have two H's on this side, I have two H's on this side. This becomes +2. How many electrons are involved? 2 electrons. And notice something, party people. This is very important. The electrons are balanced. Okay? Now you could have left it the way I did, but you should see this is the optimal way to do it. 2 H pluses to 2 H's. This side is a +2, 2 electrons. And you notice we have just written the correct half reaction. This tells me the story. This got oxidized, electrons are on the product side. This guy got reduced, its charge went down by gaining electrons. The GER, gaining electrons, is reduction. Now, I ask you 4 questions. The first question states the substance that got reduced. Who got reduced? Now, my friends in chemistry, the one who got reduced is the one whose charge went down. But I want to make this absolutely clear, because I don't want you guys ever to get this wrong again. The answers to all 4 of the questions I'm going to ask are always on this side. Redox is about what happened, or what's happening, not what just happened. Okay? If I was going to a party in West Hampton and there was illegal coffee being drinking, okay? All right, you're drinking, I don't know, diet soda you should be drinking, and I go to break up to see who's selling and who's what? Buying. Those are the people I'm after. Okay? He's selling. He's giving off the stuff. He's buying. That's illegal. Now, after that has happened, I can't really arrest anybody. Okay, it's about who is giving and who is receiving. So it's always about these guys. The answers to these 4 questions are always on this side. The answers to these questions are always on this side. The answers to these questions are always on this side. The answers to the questions are always on this side! Now, that hurt my back.
Oh God.
Somebody in here is going to pick one of these sometimes. And I'm going to kick, man, you picked one of these. So who got reduced? Who specifically gained electrons? Whose charge dropped by gaining negatives? Who got reduced? Now, if you say hydrogen, you're being too vague. Where do you live? Over there. Where you gonna drop me off? I'm over there. Over there. Where you live? Over there. Over there, what number? Over there. Hydrogen, be specific. H plus. Hydrogen actually represents this guy. H plus, you're talking about this. H plus got reduced. Its charge got what? Dropped. It specifically gained electrons. Who got oxidized? Specifically, who got oxidized? Zinc 0. Now you can say zinc means zinc 0. If you meant to say zinc plus, and I get mad. You say zinc plus too, but we're talking about the guys over here. So the zinc got what? Zinc got oxidized. So here's so the one who got reduced, okay, is H plus. The one who got oxidized is zinc plus zinc 0. Now you need we need a friend. I give you Elvira, the outermost electron. Hey! Now, if I'm getting oxidized, I'm what? I'm losing electrons. If I'm getting reduced, okay, I'm gaining electrons, but I'm gaining negatives. She's negative. Okay? So Elvira, the outermost electron, helps us here. Now, if I was an agent, what do? I help people do things. If I was a modeling agent, you all should run. No, if I was a modeling agent, okay, I help people model. But now I'm going to be an oxidizing agent. or a reducing agent? How about this? I'm going to be a reducing agent. I'm going to help people do what? Get reduced. I'm going to help this front row get reduced. So if I'm a reducing agent, I'm going to help them get reduced. Now reduction means what? Gaining or losing electrons? Gaining. So if I'm a reduction agent, or reducing agent, very clearly I help people get reduced. So watch, they got reduced. Watch. They got what? Who wants to be reduced? Here you go. They got reduced. What did I do though? What did I do to help them get reduced? I what? Got oxidized. The reducing agent, always think opposite. Say it with me. Opposite. Say it with me like you're from England. Opposite. Say it loud and proud. Opposite. Opposite. So if I'm the reducing agent, I'm the one that got what? Oxidized. If I am the oxidizing agent, I'm what? I'm helping you gain the electrons. Oxidizing agent, I'm helping you lose it, so I get what? If I'm the oxidizing agent, I get what? Think opposite. I get reduced. If I help you lose the electrons, I myself got reduced by the electron. So who's the reducing agent? The one who got oxidized. Zinc. Who's the oxidizing agent? The one that got reduced, the H+. I want you to finish the first side, please. Look over the key. Okay?
I don't get this here, how like, so does that make it H2
Zero.
or?
It makes it 2H plus 1, so plus 2 overall, plus 2 negative gives you a 0 on this side. This side's 0. Everything's balanced.
So it doesn't matter that this is just